Hello, I'm Michael Snyder. Welcome to Robotics I. One of the first things we learn in robotics is what is the difference between a machine and a robot. And it comes down to a machine which is able to sense its environment, think, or use a program to take that information and process it and act on it in some way. So to be able to sense, to think, and to act. Robotics I is the first class in a series of classes we offer here at Flint Hill. We've got Robotics I, Robotics II, and then Advanced Aerial Robotics. In Advanced Aerial Robotics, teams compete the SUAS, that's Student Unmanned Aerial Systems Competition. It's a college level competition, and we've done quite well in past years. There we are in this picture in the front in the white shirts. Right now the students are working on learning about the field of robotics, what they could expect to do in college in robotics, and what careers are available in the robotics field. Throughout the year we're going to come back to sense, think, act again and again and again. One of the first ways that we'll look at that is using the Parallax Cyberbot kit. The Cyberbot kit uses a microbit controller, and it also features a breadboard, which is nice. We're going to use that to create our own sensors. Students are going to be learning about circuits and how to get that sensor information from the sensor then to the microbit controller. We'll also be programming in Python and then using servos to get the action portion of the robot. Once we've completed the microbit robot, we are going to switch over and use the Tetrix robotics system, which is used by the first Tech Challenge competition. We're going to explore the different sensors there. We've got the ultrasonic sensor, we've got different touch sensors, and we've got compass sensors. We will be programming that with blocks. That's on Java blocks programming language that's been developed. And then we will be acting. The robot will be acting through motors. Here's some motors that have encoders built in. So a sensor that's built into this motor allows us to tell how many degrees that the axle has rotated. We'll also be using servos. We have two different size servos here, as well as continuous rotation servos. Once we've looked at the motors, we will then look at different ways of transmitting energy, or transferring energy over distance. So talking about gears, gear ratios, combining gears together, being able to either increase the torque or increase the speed of the robot based on our gears and our gear ratios, to be able to transmit energy over a distance using chain cogs. So we have some belt drives here as well. And then for locomotion, different types of wheels. We've got some regular wheels, we've got omni wheels. If your child is loving this class, wants more robotics, we've got the robotics activities first Tech Challenge competitive season. After Robotics I, students are able to take Robotics II. That's a computer-aided design class. In that class, students will learn to use Fusion 360 and then be able to utilize the 3D printers behind me, as well as our CNC machine. If you navigate on over to the Robotics I course page in Husky Hub, you'll see a link to our syllabus. In there, it details our grading policy. I got 50% for projects. The class is mostly projects. I like as much hands-on time as possible. We've also got 25% for quizzes, 10% for participation, and 15% for notebooks. I ask kids to keep a notebook because as Adam Savage, one of my heroes from Mythbusters, said, the difference between screwing around and science is writing it down. Thank you so much for watching. If you have any questions, please don't hesitate to reach out via email. Good night.